We have a unit that has a lot of factoring in it. So we're just going to practice and remember how to factor. So we have our A, B, and C. Go ahead and make your X. At the top of the X is always A times C, which will be 24. At the bottom of the X is 10. So I want you to try to figure out what two numbers would multiply to give you 24 and add to 10. Did anybody figure out what those numbers would be that would multiply to give you 24 and add to 10? Anybody know? Isaiah? Yeah, positive 6 and positive 4. Let's go ahead and make our box. We put our A here, and our C will always go here. And then the two numbers that Isaiah gave us, they go here and here. So let's take out our greatest common factors. So when you're looking at this row here, what can I take out of both of these boxes? What do they both have? So what number goes into 3 and 6? 3. So we can take out a 3 and we can also take out an X. The bottom row, we can take out a 4. Because 4 will divide into 8 and 4. The first column, we can only take out an X. And the second column, we can take out a 2. The good thing about this is that you can check it to make sure you get the answer on the inside. So we know that 3x times x is 3x squared, and 3x times 2 gives us the 6x. So our final answer would be 3x plus 4 times x plus 2. Oh, there we go. All right, so let's take out our notes. I think we're on page 5. We're going to do one more graph, and you should have time at the end of class to finish your homework. So in our notes, we're on page 5. So we're going to start off by looking for that little bitty number next to log, which in this example is a 2. So go to the bottom, and I want you to start by making your exponential table, which would be, why did I put a 2? A 3. Which would be y equals 2 to the power of x. So we're going to take 2 to the negative 1, 2 to the 0, 2 to the first, 2 to the second, and 2 to the third. which is the same table. I used to have it on the board, but I erased it. So if you don't have it memorized, this is what that exponential table would be. So we're going to start off by, we need to flip that table in order to graph the parent, which would be y equals log base 2 of x. Does anybody remember from yesterday, what do I have to do with that table in order to get the sister table? What do we do with the x and y? We flipped it, yep. So let's go ahead and do that again. So when I flip it, that means all of my x values are now going to be my y values. And all of my y values will become my x values. So let's go ahead and flip it. All right, after you flip it, we don't need this table anymore. You can get rid of it. So go ahead and graph that. Let's graph that out. And that's our parent graph. Okay. So now let's go ahead and graph our transformations. Let's look at this function here. In that function, a is 1. H is always inside of the parentheses, and you flip the sign. So what would our H value be for this equation? Diana, what would you say our H value is? Positive 3, good. And that's going to make it go right 3. Jaden, what's our K value? Positive 4, good. And that's going to make it go up 4. So in this one, the MVP is H, because H is going to tell us the domain and our vertical asymptote. So our domain is X is greater than H. And because H is 3, it's going to be X is greater than 3. And we have a wall that we're going to draw in at X equals 3. Your range never changes. That would be all real numbers. All right, so let's go ahead and do our transformations. You're always going to take the H and add it to X. You multiply Y by A and add K. But because A is 1, we don't have to do that. So you're just really adding K. So go ahead. Hi.
Hi. Is this student here today?
Let's see. Yes.
Have a good day.
Here you go, Tyra. So you're going to add the 3. To all of these numbers and add 4 to all of these numbers. So let's go ahead and do that, and then we'll graph our transformation. So pick up your calculator, add 3 to all your X values, add 4 to all your Y values. All right, so let's go ahead and draw in our asymptote. And that asymptote is going to be at x equals 3. And I like to draw this in just as a reminder that when we graph it, it can't go through this wall. So make sure when you graph it, it doesn't cross that wall. And that would be your graph. Any questions about how to graph our logs? All right, let's go to the next page and we will finish this out, y'all. So we're going to go back and remember how to rewrite things in exponential form and log form. So real quick, remember, and I wrote it on the backboard also, but the rule is log base b of a equals e. But to write it in exponential form is base to the power of e equals a. So your base, then you have your exponent, and then you have the answer. So let's take this and write it in the other form. Right now it's written as a log. Let's write it in exponential. Okay. So for the first one, it would be 19 to the power of 2 equals 361. I'm going to go ahead and freeze my screen, and I want you to do 2, 3, and 4 on your own. And then you can compare your answer. All right, who agrees with my answer? Go ahead and check it. So for number 2, it would be 7 to the power of 3 equals 343. For number 3, it's 15 to the power of 2 equals 225. And for number 4, it's 18 to the power of negative 2 is equal to 1 over 324. Any questions about that? Nope, pretty easy. All right, let's do the next row. Now let's go the other direction. Write this in log form. So here's our rule. Let me just write it up here again. And then take a minute and try to do that row. First step you got to do is write the word log. So for the first one, it would be log. And make sure when you're doing that base, it should look like it's in the dirt. So in other words, it shouldn't look like this. That's not what a base looks like. A base, when you're writing it, it should look like it's being pushed underground. So notice how the 5 is under the word log, kind of it's like pushed down. So it's log base 5 of 1 equals 0. All right, and then I'll give you a minute to do the other 3. All right, so you should have log base E of y equals x, log base 16 of 256 equals 2, and the log base 4 of 1 over 16 equals negative 2. Any questions? All right, so now is the row we skipped on our homework. Let's talk about what does this mean when it asks us to evaluate. When you see the word evaluate, that means find the exponent. That's what that's telling us to do. So they didn't tell us what the exponent is. They want us to figure it out. So in order to do that, the first thing I like to do is I set it equal to x, and then I rewrite it. So set it equal to x, and then rewrite it. In exponential form. So that's how we're going to start this out whenever it asks us to evaluate. So if I set number 1 equal to x, it would become 3 to the power of x equals 27. And then use your calculator to figure out what our exponent has to be. 3 to the what power is going to give me 27. Don't say it out loud. Go ahead, you can do trial and error. Try to figure out how many times do we have to multiply 3 to get to 27. 3 to the what power will give us 27. Give me a thumbs up when you figure it out. I'm not going to call on you, I just want to see. Show me with your fingers what exponent you came up with. You're right, it's 3. If you type in 3 to the power of 3, you do get 27. So that means that x equals 3, and that is my answer. So when you're asked to evaluate, you have to find the missing exponent. Let's look at number 2. First step, set it equal to x. Second step, rewrite it. Don't say it out loud. Try to find your exponent. 12 to the what power is 144? Huh? This is the notes. We're on page, what page we on? 6. So 12 to the what power would give us 144. Show me with your fingers when you figure it out what the exponent has to be. 2, you're right. All right, number 3 is kind of tricky because they didn't put the base. So here's the thing. I don't know if you've learned this yet, if you've had ICP or chemistry, But the base of a log, if you don't see it, is 10. So when you look at your calculator, does everyone see that there is a log key right under the green button? That log key has a base 10. So whenever the base is 10, we don't write it. So let me go ahead and put that in. There's a base 10 right here, which means this is 10 to the power of x is 1,000. So I'll give you a minute to figure out what your exponent has to be. Whenever a number is not there, it's 10. Show me with your fingers, what's the exponent? 3, good job. All right, last one, number 4. They told us the base is 5. 5 to the what power is 25. And show me with your fingers what you come up with when you have an answer. All right, good. Let's take out our homework. Just a reminder, homework is due not tomorrow. Fix that. Monday for full credit, and we'll use this time to work on a few of those questions together.